Welcome to a lesson with Dr. Powell. Let's take a look at Simpson's rule. It's a way of approximating a definite integral. And we actually get exact results for polynomials up through cubic polynomials. This is a quadratic polynomial, and it's going to give us an exact result. And no matter even how many subintervals we use in certain pieces of this process. It's kind of a fun idea. And it has to do with how things weighed out in series expansions of whatever we're integrating. Okay, so let's take a look at this. It's going to be 2/3 times the midpoint rule plus 1/3 times the trapezoid rule. So let's look at a picture, remind ourselves what these are. So this is x squared plus 1. And let's look at from 0 to 2, and let's split it up into, let's give 2 subintervals for each of these. So first, let's look at the trapezoid. The trapezoid is just like doing this, finding the areas of trapezoids. Now, one way of doing this is just do a left-hand rule and a right-hand rule and take their average, because finding the area of a trapezoid is like taking left and right of the trapezoid, adding together, dividing by 2. So finding the average of the two lengths and then multiplying by the width. And we really do the same thing when we do left-hand rule plus right-hand rule. So left-hand rule means we take we look over to the left of each subinterval, and we just take that as our height on each one, like this. So, and we can do that just by adding together all the heights, except don't add the rightmost, just add the others. So the heights respectively are 1, and if we plug in 1, we'll get 2. So we plug in 1. So the left-hand rule is 1 plus 2 times the common width, which is 1. Now the right-hand rule is, so we look this way, so it's equivalent to just taking the sum of all the heights, except don't include the leftmost. So we do 2, and this height over here is 5. And so we get 2 plus 5 times 1. We take the average of all this. So on the top, we get 10 over 2, which is 5. So the trapezoid rule will give us a 5. Okay, now what about midpoint rule? So, and why is midpoint rule such a good approximation, better than trapezoid? Trapezoid looks pretty nice, the way you can make trapezoids out of it. But midpoint rule actually is a little bit better and a little bit more accurate. And hence it receives a little bit more of the weighting. Why is that so? Well, first of all, the midpoint rule can be thought of as taking the middle point on the x portion of the rectangle. So right here, just take the middle x value and go straight up wherever you hit. Go right across, and then you have a rectangle. Here, the middle and xy's of the subinterval, and you go straight up wherever you hit, and you make a rectangle. Now you can pivot this line about that where we've hit it right here, and you still maintain the same area in this shape right here. And that's because you have this nice symmetry here being in the middle right here. So now in particular, you can pivot it so it becomes the tangent line even, and that's kind of nice. So it's like taking the tangent line and approximating by the tangent line and drawing it and then finding the area under that. That's pretty good approximation, actually. So let's compute that. So to compute it, though, we're going to use the rectangle idea. So we just need to take, in fact, since the widths are just 1, we're basically just adding the heights right in the middle. The height right here, we plug in a half into this. And so we end up getting 5/4. Here we plug in 3 halves. So we end up getting 13/4. Added together, that would be 18/4. which is the same as 9/2. So the midpoint rule will give us 9/2. And if we work this out, multiply that out, we end up getting 3 plus 5/3, which would be 9 plus 5, so 14/3, as our approximation using Simpson's rule. Now, let's try this out, actually. If we integrate this, we get x cubed over 3 plus x. Let's go from 0 to 2. We get 8/3 plus 2, which is 14/3. The same. It was exact, even though we only use so few subintervals. Now, commonly for Simpson's rule, we actually say, notice how we were evaluating things here and here and here at these points. Now, if you look at that, it looks like there's been like 4 subdivisions. So twice as many as what we use for midpoint and trapezoid. So whenever we say use Simpson's rule with a subinterval like 4, really what we mean is half that number to be used for midpoint and trapezoid. So only using 2 for midpoint, 2 for trapezoid, and which is kind of nice. And then we can compute that. Thanks for watching.